Study Section 8 Regression Analysis Introduction. In this study, you will be introduced to the theory of linear regression analysis. Different types of relationships shall be shown on the scatter plot, and the estimate parameter of the model shall be obtained by method of least squares. An introduction to the text of significance of the regression line will also be given. Learning outcomes for study section 8. At the end of this study, you should be able to discuss the concept of regression analysis, identify the types of regression models, estimate the parameters of a regression model, and explain the testing of the significance of the model. Regression analysis. Regression analysis is a statistical tool which helps to study the trend and pattern of movement in one variable in response to changes in another variable on the basis of an assumed relationship existing between them. Once this pattern is established, it can be used to predict one variable from the other. The variable being predicted is usually referred to as the response-dependent variable, and the other variable is called the explanatory independent variable. The values of the explanatory variable are usually fixed and under the control of the investigator, while the values of the response variable are determined by the values of the explanatory variables. Thus, regression analysis attempts to determine how changes in the explanatory variable affect the response variable. The variables involved are assumed to be measured and recorded as interval-scaled or ratio-scaled data. If the variables are strictly qualitative, that is, attributes, the method of regression cannot be used. The appropriate method used in studying association between two qualitative variables will be discussed. In-text question. Types of regression models. A regression model may be simple, multiple, linear, non-linear. A regression model can be simple if there is only one explanatory variable, and multiple if there are more than one explanation variable. A regression model is linear if its parameter does not contain any exponent and are not multiples of other parameters in the model. Otherwise, the model is said to be nonlinear. The value of the highest power of a model is called the order of the model. Scatter plot. The first step is the study. Take 2. The first step in the study of the relationship between two variables is to draw the scatter diagram. It portrays the direction, form, and strength of any relationship between quantitative variables. It is drawn by plotting the values of the response variable on the y-axis against the values of the explanatory variable on the x-axis. The shape of the scattered point on the graph gives an idea of the type of relationship between the two variables. Types of scatter diagram. Figure 8.1 shows some of the common types of relationships that exist between two variables. Figure 8.1a depicts a linear relationship. Figure 8.1b and c depict nonlinear relationship. Figure 8.1a is a quadratic relationship, while figure 8.1c is an exponential relationship, while figure 8.1c shows no relationship between variables x and y, that is, spacious relationship. Since neither a line nor curve can be fit on the scatter plot, please note that 1. Scatter plot cannot be used for more than two variables. 2. A non-linear regression model can be made linear through appropriate transformation. In-text question. The simple regression model. The simple linear regression model describing the relationship between the response variable y and the explanatory variable s can be expressed as yi is equal to beta 0 plus beta 1 xi plus ei for I is equal to 1, 2 to n, where there are n observations on both x and y, and 1. yi is the ith observation on y. 2. xi is the ith observation on x. Beta 0 is the intercept, the point at which the regression line crosses the y-axis, that is, when x is equal to 0. Beta 1 is the slope regression coefficient of the line. It gives the rate of change in y per unit change in x. EI is the error time distributed random error term with mean zero and variance. The parametrics of the model can be estimated by method of ordinary least squares (OLS). Basic assumption of OLS. 1. The relationship between x and y is assumed to be linear. 2. SIs are predetermined, fixed values assumed to be measured without error. 3. The error time EIs are independent of x, that is, EIX in bracket is equal to 0. 4. The error term is assumed to be normally distributed with mean zero and variance. That is, the above assumptions implies that is a random variable with the expectation mean. EYI in bracket is equal to E into bracket alpha naught plus beta 1 xi plus EI is equal to alpha naught plus beta xi. Since the two symbols are constant and E into bracket EI is equal to 0, similarly, where variance E can be estimated by estimation of parameters. Suppose there are n pairs of observations on x and y as the assumed linear relationship is where A and B are estimates of x0 and x1 in the original model. Equation 8.1 can be expressed as let Q is equal to the constant can be obtained by minimizing Q with respect to A and B. That is, the normal equations 8.4 and 8.5 can be solved simultaneously to obtain and B is equal to, and variance can be estimated by where yi is the observed value of y. Yi is the estimated value of y, and the variance of the intercept is, and the variance of the regression coefficient is coefficient of determination. This is the proportion of variation in the response variable y that is explained by the explanatory variable x. It is defined by is equal to explained variation over total variation, where 0 is less than or equal to r squared less than or equal to 1. R squared is equal to 0 when b is equal to 0 and r squared is equal to 1, when all the points fall on the fitted regression line. Testing the significance of the model. It is always desirable to test the significance of the model, that is to examine whether a regression line is a good fit. If the line is a good fit, then all the points on the scatter diagram must fall on the line or lie very close to it. This can be done by examining the residual plot, that is, plot of residual error. ER is equal to yi minus yi in bracket against the data points. The most objective method is by arranging the sum of square and cross products in an analysis of variance ANOVA table and carry out the Fisher's test, F-test, or student t-test as follows.